Hello my dear friends, how are you? Let's do the remaining questions of ADC. In a 5-bit weighted resistor DAC converters, the resistor value corresponding to the LSB least significant bit is 40 kilo ohms and the resistor value corresponding to MSB will be C. DACs क्या करते हैं? As you can see, DAC means that convert binary or non binary numbers and codes into analog ones, right? With its output, like इसका output क्या होता है? It can be voltage or it can be current, being proportional to the value of its digital number, digital input number. So in an n-bit weighted resistor DAC, there are n resistors. In an n-bit weighted resistor DAC, there are, so resistances are 2 to the power 0 R, 2 to the power 1 R, 2 square R, and up to 2 to the power n minus 1 R, where R is the resistance used and it is the resistor value of corresponding MSB and it is the value of the corresponding LSB, right? So n is the number of bits. So given here what we have given here, uh, here the resistor value corresponding to LSB, our LSB is given as 40 kilo ohms, right? Our LSB is given as 40 kilo ohms, and since n minus 1 R is equal to what? It is equal to LSB. For a 5-bit comparator, n is equal to 5. We have 2 to the power 5 minus 1 into R is equal to what? 40. 40 kilo ohm. So R is equal to 2 to the power 4 into R is equal to 40. 40 kilo ohm. So it is what? 16 na? 16 R is equal to 40. So R is equal to 40 by 16. Okay, right? So it will be 4 4 ja 16, 4 10 ja 2 2 ja 4, 2 5 ja. So it is 2.5. So it is 2.5 kilo ohm. So R is equal to 2.5 kilo, right? Next question is, a single slope ADC shown below is used to convert an analog input of 10 volt to digital. The digital output if the clock frequency is 250 megahertz is C. We have what here? As you can see, there is an op-amp, there is a clock. It is given to one of the AND gates. It is a 10-bit counter. Okay. So we have what? We have, this is V minus inverting input. This is non-inverting input. So V minus is equal to VC. Right, here it is voltage across capacitor. Initially what we have, VC is equal to 2 volt and V input is equal to how much? V input is 10 volt, it is given here. Okay, so it is 10 volt. As this V input is greater than VC, this 10 is greater than 2, the output of comparator is 1. The clock pulses reach the counter. Clock pulses are going to reach the counter. You know, counter counts the number of clock pulses applying at its input. So the time required by the capacitor to reach 10 volt, it is, you know that I is equal to C dV by dt. So we have to calculate the dt. So it will be C dV upon I, right? So when I am going to integrate it, it will come out to be as T is equal to C V by I. So it will be as uh, T is equal to CV by I. So C is how much? It is 25 picofarads, 25 into 10 to the power minus 12. And here voltage, it is how much? It is VC is 2 volt. Here, as you can see, here it is given that VC is 2 volt and this is your V input and this is VC. So here voltage will be V input minus VC, that means 10 minus 2. And current is how much? Current, it is given as 10 milliampere. So it is 10 into 10 to the power minus 3. So it is around 10 minus 2 and it is 10 minus 12. So it is 10 minus 10. Okay. So what it is come out to be? 25 into 10 minus 10 into 8. So it will be 200. So it is around 20 nanoseconds, right? So as the initial voltage is 2 volt. Initial voltage is how much? It is 2 volt. As you can see, initial voltage is 2 volt. We will take V dash is equal to 10 minus 2 is equal to 8 volt. Now clock period. See, this is clock period. This clock period is equal to how much? It is, you can say, it is 10 250 picofarad it is. So एक minute, 1 minute, it is t clock na, so t clock is also equal to 1 by clock frequency. So it is, if it is given as 250 megahertz it is given, okay. So t clock will be equal to 1 by clock frequency, it is 1 by 250 megahertz to 10 to the power minus 6 by 250. So it is coming out to be 4 nanoseconds. So digital output will be what? Your digital output will be this time required by the capacitor by the time required by the clock. So it is around 20 by 4, that means it is 5. So the answer will be, it is come out to be 5. Have you understood the question? What it is given here? See, what you have to do, you have given an A to D converter, right? You have given input voltage as 10 volt. You have given initial voltage across capacitor is 2 volt. This is also the initial voltage, right? And you have to calculate the digital output in decimal. Decimal, that means you have to calculate this much. For this, what you have to do, you know that I equal to C dV by dt, so you have to calculate the t of capacitor. So it will be C by I into V. Now this V will be equal to V input voltage minus capacitor voltage, and this capacitor is around 225 picofarad. As what you are, so you have calculated the time required by the capacitor, then you have to calculate the clock frequency. Then clock frequency is megahertz, and for the digital output you have to take the ratio of the clock period, capacitor, uh, time required by the capacitor to the time required by the clock, okay. So just 5. Now next question is this one, okay. Consider an 8-bit DAC with reference VR is equal to 5 volt, okay. This is 5 volt. Now the smallest value of R which will limit the current drawn from the supply VR to 10 milliampere is, see, maximum current, because what you have given here 8-bit DAC, that means N is equal to 8, you have reference voltage is equal to 5 volt. So maximum current drawn, okay, maximum current drawn from VR when input is 1 1 1 1 1 1 1, right? All nodes, see, all nodes are connected to VR. This one, this one, this one. We have all nodes are connected to VR. So what we have to do, you have overall current is how much? 10 milliampere, and this is equal to VR by R plus VR by 2R plus VR by 2 to the power 7R. Now you have to take out the common, 1 by 2 to the power 7 into VR by R, and this will be equal to how much? 2 to the power 0 plus 2 to the power 1 plus up to 2 to the power 7. Then what you have to do? Then again 1 by 2 to the power 7 into VR by R, 2 to the power 8 minus 1. So it will come out to be as 255 by 128 into VR by R, right? Okay, so this is equal to 10 milliampere. Now you have to calculate the R. So this R minimum is equal to what? This is equal to 255 by 128 into, yes, VR is how much? 5 volt. So 5 by 10 milliampere. So 5 by 2, and then 2 1 ja 2, 2 2 ja 4, and 2 7 ja 14, this much. So it will come out to be as 996, right? So answer will be your 996 ohms, right? This is the formula. Okay, we will calculate, we will learn more about this ADC and DAC. Till then, please like, share, and subscribe. Okay, so thank you very much.